If you've tried to get GPUs for an AI project lately, you've probably discovered the real bottleneck isn't code. It's power, permits, and, weirdly, physical stuff like factory robots and hospital devices. So here's the twist. In just 1 week at the end of 2025, 3 headlines collided and quietly reset the roadmap for cloud infrastructure in 2026. The U.S. House moved to fast-track AI data center permits. ServiceNow agreed to spend $7.75 billion on a company that secures physical devices. And Oracle boosted its cloud infrastructure spending to $17 billion because demand, driven by AI, keeps piling up. Let's slow that down for a second. If you work anywhere near enterprise tech, your next AI cluster might depend as much on policy and power as on model choice. And security now stretches from virtual machines to the robots on your factory floor. That's a big deal. Now, here's what actually happened. In early December, Oracle said it's raising its infrastructure capital spending to $17 billion for the fiscal year, about $10 billion more than it planned, because its cloud backlog is now over $100 billion. Backlog is basically signed demand that hasn't been delivered yet. In other words, customers have committed to a lot of cloud, and a meaningful slice is AI-related. A week later in Washington, the U.S. House passed something called the SPEED Act. The goal, speed up permits and environmental reviews for AI data centers and the power projects that feed them. It's aimed at the real-world jam of getting new capacity built in time. It still needs the Senate and the President, so it's not law yet, but it's a signal about where things are heading. And just before the holidays, ServiceNow announced it's buying armies for $75 billion in cash. Armies finds and secures unmanaged devices, things like building controllers, factory equipment, medical pumps, and other connected devices that don't show up in your normal IT inventory. The plan is to fold that into ServiceNow's platform so organizations can see cyber risk across both cloud systems and physical operations. Put those together and you get a clear picture. More money flowing into AI infrastructure, a push to remove the permitting brakes, and a security perimeter that now includes the physical world. So let's unpack how each piece works, without getting lost in the weeds. First, the permitting push. The SPEED Act tries to compress the time it takes to approve big infrastructure like data centers and power connections. Think of today's process like a single-lane road with speed bumps. Each review or hearing slows things down. This bill is like adding passing lanes for projects tied to AI capacity, so they can move faster without getting stuck behind everything else. In other words, it doesn't create more electricity by itself, but it can get shovel-ready projects out of neutral. That matters because AI data centers are power-hungry. Some projections say U.S. AI data centers could need far more power by the mid-2030s. The exact number is debated, but the direction is clear. Here's the catch. The House passed it. The Senate hasn't. There will be debate, especially around environmental reviews and local community impact. So treat it as a strong indicator, not a done deal. Now the security piece. What does cyber-physical mean in plain terms? It's the idea that software systems and physical devices are now intertwined. ET is your cloud apps, databases, and networks. OT, operational technology, is the stuff that runs your buildings and factories. HVAC controllers, robotic arms, power systems, medical devices. Armies' specialty is finding those devices quietly on the network, even when no one has them listed. That's called passive discovery. It watches traffic and fingerprints devices without poking them. The value is simple. You can't secure what you can't see. ServiceNow buying armies means they want your incident management, asset inventory, and risk workflows to include those physical devices alongside cloud assets. So a misconfigured factory gateway or a vulnerable building controller doesn't sit in a blind spot. It's visible, prioritized, and fixable, right next to a cloud misconfiguration. So let's slow that down. In other words, your single pane of glass is spreading from racks to robots. That's where many teams get surprised. Finally, the spending surge. Oracle boosting CapEx is about building high-density regions that can host big GPU clusters, high-speed networking, and fast storage. This is the groundwork for AI workloads, training large models, fine-tuning smaller ones, and running inference at scale. When you hear backlog, think of it as a long line of reserved capacity that needs to exist somewhere, soon. Here's what actually matters here. AI demand is real enough that providers are changing where they spend money, how fast they build, and what they consider in scope for enterprise risk. That means your cloud strategy might need to account for energy availability, permitting timelines, and physical device security, things that haven't always been front and center for software teams. So, what changes for you in practice? Short term, if permitting reforms stick, US regions could come online faster, especially zones tailored for AI. That could ease waitlists for GPUs and make planning less of a guessing game. Not overnight, but sooner than the old timelines. Long term, where you run AI will track where providers can get power at scale. Region selection becomes partly an energy decision. If your board cares about sustainability, that will intersect with performance and availability choices, not sit off to the side in a separate report. And the risk perimeter. In healthcare, manufacturing, and critical infrastructure, the expectation shifts. Leaders will ask for unified visibility across cloud apps, data center gear, and frontline devices. The line between IT and OT starts looking like a dotted line. Let that sink in for a second. The cloud strategy conversation now includes the grid, regulators, and the factory floor. There are trade-offs to watch. The SPEED Act could face pushback. Speeding up approvals raises questions about environmental impact and local control. Even with faster permits, grid constraints are still real. You can't allocate GPUs that don't have power behind them. Cyber-physical convergence expands the attack surface. More connected devices mean more places to get in. Visibility helps, but it also means handling sensitive operational data carefully. Privacy, safety, and reliability now share the same table. The CapEx race signals confidence, but it can increase vendor leverage. Big backlogs and specialized AI stacks can make it harder to switch providers later. Lock-in isn't new. It just looks different when it's tied to accelerators, interconnects, and managed AI services. So let's pause and summarize. Faster permits aim to unlock capacity. Security platforms are reaching into the physical world, and providers are spending heavily because AI demand looks durable. The key thing here is alignment. Energy, risk, and spend have to move together. What does 2026 look like if this plays out? Energy becomes the hard limit, not features, not even capital. The regions that matter will be the ones with reliable power, fast interconnects, and supportive policy. You'll hear more about on-site generation, grid partnerships, and creative cooling. You'll also see providers talk more about how they balance performance with carbon goals, because boards will ask. At the same time, exposure management becomes a kind of control plane. That phrase, exposure management, just means finding and prioritizing risk across everything you own or touch. In plain English, know what you have, know what could go wrong, and fix the right things first. The new part is, everything now includes OT and IoT. The analytics you use for cloud logs and traces may pull in building telemetry and factory alerts too. And cloud platforms will lean into end-to-end AI stacks, not just GPU counts, but the whole runway. Networking that keeps accelerators talking fast, storage that feeds them without stalls, and managed services that shrink time to value. It's great for speed. It can be tricky for portability. Here's a concrete picture. A hospital CIO could patch a cloud EHR and a networked infusion pump from the same workflow. A manufacturer might correlate an anomaly on a robotic line with an alert from a cloud MES system and cut downtime because the picture is unified. That's the promise. The work is mapping data models and governance, so the picture is also accurate and safe. If you're exploring this space, a few practical takeaways stand out. Treat region planning as an energy decision. Ask providers about power contracts, grid timelines, and on-site generation for AI zones. It frames realistic capacity expectations. Build portfolio resilience on purpose. Don't overextend, but design at least one viable alternative region or provider for critical AI workloads. Even a partial failover plan reduces risk. Extend your asset inventory to OT and IoT. You don't need to boil the ocean. Start with the devices that can affect safety, uptime, or sensitive data. Fold them into your existing incident and change workflows. Align security with operations. If your SRE team can remediate a misconfigured VPC in minutes, aim for a similar path for a misconfigured building controller or factory gateway. Contract with portability in mind. Accelerators and interconnects are sticky. Where you can, negotiate clarity on reserved capacity, exit options, and data egress so future shifts aren't blocked by fine print. Now, a quick reality check. Permitting reform isn't magic. Even if federal timelines shrink, local constraints and grid upgrades take real time. And cyber-physical integration needs thoughtful guardrails. Who owns the data? Who can act on it? And how safety decisions get made. The wins are real, but so are the coordination costs. So, why does all of this matter now? Because 2026 cloud strategy isn't just about where to run a model. It's about how fast capacity can show up where you need it, how visible your risk is across both software and physical systems, and how much leverage you have with vendors whose AI pipelines are booked for years. The organizations that factor power, policy, and physical risk into their planning won't move slower. They'll move with fewer surprises. One last digest point. If you remember nothing else, energy sets the pace, exposure management anchors trust, and CapEx tells you where the runway is being paved. Everything else hangs off those three. And if you're an engineer or a leader who has felt frustrated by GPU scarcity, this is the context. It's not that providers are holding out on you, they're racing the clock on power and permits, while security teams widen the lens to cover the physical world too. It's messy. It's also progress. That's the story for now. If this was helpful, consider subscribing for more tech insights. A like helps others find it. Thanks for watching.